Well, hello everyone. Welcome back to the channel. We are back again with another brand new video, and this video we are continuing with our study of structures in C. And in this video, we are going to solve some more problems on structures. Preferably, these problems are going to have a little more complexity, like they're going to involve doing some actions on structures like looping or sorting through them and so on. So, without wasting any further time, let's dive right into this video. So, we've got 5 problems to solve. I'll just quickly show you all those 5 problems. So yeah, these are the 5 problems that we are going to solve as part of this video. So as you can see, these are the 5 problems. You can maybe stop and do them on your own, but I'd recommend you guys come along. What you can do is you can just take a look at the problem that we're going to solve right now. You can pause the video, you can solve it, and then you can continue with the discussion later on in the video. Like you can see how I did it versus how you did it. Okay, so that it's easier for you to understand as well. Now let's get started with the first problem. The first problem states us that we are given a set of n points and a point P. We have to write a C program to find the point in S which is closest to P, right? So let's understand this problem and then, let's code it out. So let's get to our notepad. Okay. Let's say we are given some points. Let's say we'll be given an n. We'll be given n points for x1, comma y1. Then we'll have x2, comma y2, right? And then we'll have x3 comma y3 so on till xn comma yn. Okay, and given a point P, let's say P comma Q, for all these points we have to check which is the closest point. Okay, so what I want from you guys is not to think about this problem as a structure problem or anything like that, right? This is a very simple problem. Suppose if I had given you a question to solve, like given a list of integers 1, 3, 4, 5, 7, let's say 10. Find the integer which is closest to 2, right? What will you do? You will basically, let's say in this case it's sorted, so you can stop your search at 3 itself. But again, if you don't know, you will compare 2 with 1, let the difference be -1. You'll contain 2 with 3, and the difference is again, like absolute difference is again 1. So 1 and 3 both are closest to it, right? And then let's say 4, the difference becomes 2. With 5, the difference becomes 3. With 7, the difference becomes 5. With 10, the difference becomes 8. So accordingly, you will basically loop through all of the integers, and for the integer which you find the late minimum value, you'll store that as the answer, right? So your every point when you loop it through, your integer, let's say answer is equal to let's say the first value in the array, which is, let's say, error of 0. Okay, we start from 1, and let's say int difference is equal to 1, and we start for I from 1 to, let's say, n minus 1. What we do is we check if difference of this value, difference of I and the given point P comma Q, sorry, if the difference of I and the given number 2 is less than the current difference, our difference becomes the current difference. Okay, and our answer becomes this value, so ARR of I, right? So on, after we finish off this loop, our answer will be stored in the answer value, which we can just print using like cout answer. And similarly, what I want from you guys is to have a structure of point representing point x comma y, and then you just use a structure as any normal type such as integer, and then just do this comparison. So let's dive right into code and solve this problem using structures quickly. All right, let's start solving this problem now. So we have to, given, let's say, n points, let's take the input from the user, scanf percentage d ampersand n. We have taken the input, and then let's just for int I equal to 0, I less than n, I plus plus. Let's take, let's define int x comma y. Let's take these inputs, so scanf percentage d ampersand x comma ampersand y. Okay, and then we need some way to store all these points, right, given to us. So we would use an array, right? So let's say we need an array of points, similar to how we would have an array of integers, right? So similarly, we need an array. But first, let's define what points are. So I'm gonna do a struct point with capital P, so that it's better to represent as a type. It's a good idea. So struct point, let's say we have integer x, integer y. These two things we have in a point, and let's, so that we don't have to unnecessarily write struct point everywhere, let's define type def struct point to point, so that we can just use it becomes an alias basically. So instead of writing struct point everywhere, you can simply write point after this code. Okay, right, so let's continue now. So we have scanf %d ampersand this, and then we can create a new point. So point p equal to x comma y, and we can just put this. So let's create an array of points. So point, right, let's say points, let's call it points. Okay, let's say we'll have n points, right? So points of n. All right, and then we'll just do points of I equals p. Okay, right, so let's just quickly give a check to this, and let's just do a for int I equal to 0, I less than n, I plus plus, printf %d comma, let's say we need to %d space %d backslash n. Let's print these points. So let's say points of I dot x and points of I dot y. Okay, let's just check if our input is coming fine or not. Okay, let me make this a little more bigger. Yeah, so gcc -10 closest point dot c dot out. Let's give 3 points, 1 2 2 3 3 4. Yeah, the input is coming fine. So with that, let's just take the point for which the user is interested in. Okay, so the user might be interested in, let's say we have, so given point, so let's say point given underscore point. Okay, and let's just take this input. So what I'm going to do, I'll just duplicate this line. Yeah, so here we have the point. So we'll have our given point equal to, or rather we can just directly do ampersand given point dot x given point dot y. Okay, this is done, and now we have to find the point which is closest across the given points to this given point. So we also need, let's make a function which gives us the distance between 2 points. Okay, so let's say it represents us a double distance. Okay, double distance of points. Let's say it takes a point p1 and a point p2. Okay, and the distance formula is x2 minus x1 plus y2 minus y1 whole square under root, right? Let's include math also, hash include math.h. Okay, so the return value should be square root of x2 minus x1. So p2.x minus p1.x whole square is basically multiplying this with this. So we just do this plus, let's copy this same thing again and put it here, and then just replace x with y. All right, so y and y. Okay, so now this returns us the distance. So under root of x2 minus x1 whole square plus y2 minus y1 whole square. Cool. Okay, yeah, so now let's just do for int I equal to 0, I less than n, I plus plus. As I said, the algorithm, let's start from 1. Let's consider the first point is closest by default, right? So point answer is equal to points of I, points of 0. Okay, and the difference that we have, double difference is equal to distance of points between given point and the points of 0, which is the answer. Okay, so now for every other point we just check if distance of points of given point and the current point is less than the original diff that we have, we reduce our diff. So diff becomes this minimum, which is, or we can, I think, directly, not sure min function is there or not, I will just directly use min function. So we'll have diff is equal to min of, but no, right? We cannot use min because then if min changes the value, we'll not know if when to update the value of answer variable as well, right? So let's not fall into that trap. So then difference becomes yeah. So rather calling that distance, it should be difference. It should be distance, right? Makes more sense. Yeah. So distance is equal to. So let me just calculate. So let's say it's in, let's say double current distance. So I'm gonna call it distance is equal to distance of points. Okay. Right. And then we have distance is less than diff. Then distance is equal to distance, and answer becomes points of I. Okay. After this loop, we are done. Answer is stored in the answer variable. %d answer dot x answer dot y. Okay, let's run this code. Less than diff. Okay, so this should be distance. Oops. Yeah. 1 2. Oops, I should give 3 points. Let's say 1 2 2 3 3 4, and the point we need to find distance is with 1 2. This is fine. Let's take another test case. Okay. We need to think of another test case. So let's jump to our notepad and let's try to think of another test case. Let's say 0 comma 0. Let's say this is 1 comma 1. Okay. Let's see, this is 2 comma 0. So 1 comma 1. This is 1 comma 0. Okay. Let's check for the point which is closest to 3 comma 0. The answer should be 2 comma 0. Right, so let's give our code 1 2 3 4 5 points. So 0 comma 0, 1 comma 0. Let me just show you the code as so we have 0 comma 0, 1 comma 0, 1 comma 1, 2 comma 0. Right, and let's give one more point. Let's say 1 comma 2, and let's find the closest point to 3 comma 0. Yeah, so the correct answer is 2 comma 0, and yeah, we get it through that code. So I hope the logic was clear. It's nothing difficult. It's simple only. So yeah, so this is the solution for this problem. In the next video, we're going to check the solution to the second problem. So I hope that first problem was easy to conquer for you guys as well. And if you have any doubts, feel free to post them down in the comment section or reach me via any of the handles socially visible to you on my screen. You can follow me on Instagram as well to connect with me and ask me questions via DM directly. And if you're enjoying this video, make sure you give this video a thumbs up and also subscribe to the channel if you haven't already. And now let's continue solving to the second problem. Alright, so the second problem states us that given details, name, employee ID, joining date of n employees in an organization, write a C program to find the number of employees who have got unique joining date. Alright, so we are given name, we are given employee ID, and we are given joining dates. And joining date can itself be of the form hour, minutes, seconds. So I think we need to maintain two structures here, one for employee itself and one for the date itself, right? So let's understand that. Let's get into discussion on our notepad and let's continue from there. So let me just quickly switch to that. Yeah, here we are. Okay, so we have name. Let me just come closer to my mic. Yeah, okay. So we have name, or we have employee ID, we have joining date. So this joining date can itself be in hours, minutes, and seconds. Okay. I think we need two structures to basically represent the data given to us. One will be the employee, so employee structure. It will contain a string which is basically character array of name, let's say of size not more than 20. We'll have an employee ID which let's say is also, or let's make it integer, so int ID. Okay, and then we have, let's say, joining date as well, which is of type date. So date, let's call it joining underscore date. So let's define this date structure as well. So we'll have something like a struct date, and this struct date will contain int hours, not hour, minute, second, like it will have month, year and date, let's say. So int, yeah, right, it should not be like this. Let me just undo this. So let's say joining date should be int date, int month, and int year. Years, okay, year, right? So now in order to, like, let's say we have employees now. So in order to find the number of employees who have unique dates, first of all, what we can do is we can go through each and every um, employee and check its date. Okay, so for a given employee, let's say its joining date is 20, let's say March 2021. Okay, we have to check if we've already seen a given date like this before. So what you can do is, either there are two approaches to solving this, so we will discuss both of them. Okay, so first approach is to basically maintain a structure in which you store all the dates that you have seen already, or basically what you can do is you can run two loops. So I'll tell you what I'm talking about. So let's say we have one employee who's joined on 20th March 21, let's say. Then another employee who joins us on, this is one, okay, the second employee joins us on 21st March 2021. Let's say third employee joins us on 21st April 2021, which is not even come yet, but it's okay. Then we have 20th March 2021, again another employee joined us, 5. So we'll have, let's say 22 March, an employee joined, let's say 6, an employee joined us on 21st March 2021. Okay, what you can do is one approach, the easier approach I'm telling you guys. Let's say this is easy. Okay, so we start by comparing, taking this first one. We check, is there any other date similar to this 20th March 2021? No, yes, we found it similar. So this means that this is not unique. So we stop our search for this, and then we continue 21st March. We'll not check for the back one because it's already covered by the previous one already. Okay, so 21, let's see if it's already 21st. Okay, 21st March, 21st March, let's say we'll have 21st April is not same, 20th March is not same, 22 March, and then 21st March again. So this is also not unique. Okay, let's go to 21st April. We don't see 21st April, so this is unique. For 20th March 2021, we don't see any 20th March again, right? We do have a 20th March here. So what I said, we have to basically loop. Yeah, so what we have to do is for every element, let's say for int I equal to 0, I less than n, I plus plus, we also have to pick the element, let's say for int j equal to 0, j less than n, j plus plus, if joining date of employee, so if emp dot joining date is equal to, we'll see how this equal to operation will work. So if emp dot joining date is equal to, let's say emp of I dot joining date, so let me just undo this. Let me write, so emp of I dot joining date equals emp of j dot joining date, right? Then we just break out of this loop and we continue basically, and we make a flag, let's say something, let's say bool unique equal to, let's say true. Okay, and before breaking, we'll just say that this is not unique, so we'll make unique equals false. All right, and when we say that, after this loop, which this for loop ends, we'll have something like if not unique, sorry, let's say if unique, sorry, yeah, we'll say if unique, don't worry, we'll code it out and we'll get more idea, but again I'll explain this again. So if unique, then just we just have to present the counts, right? Let me just quickly check the problem statement once. So find the number of employees who have got unique joining date. So let's say we just count the number. Okay, find out the employees, just print. If so, we'll say that count plus plus. We'll have a variable initialized to 0 initially, and yeah, so that's the end. So the algorithm is basically pick one date, cycle through all the dates that we already have. If any of them matches, discard that date, then go to the second one. Again, do the same search. So for all of them, check for how many of them you're not able to find an existing pair already. And that's all. So let's code this out and then we'll talk about the second approach, which involves sorting as well. Okay. Yeah. So let's come back to our code editor. Let's say we have a unique joining date underscore first. Let's say first approach. I made it C++. Let's see again. Yeah. We have hash include stdio.h, hash include stdbool.h is also required, right, for boolean. Okay, so let's make our int main. Let's return 0. All right, and then we have yeah. So let's say we are given n employees, so int n. Let's take the input from the user. So scanf %d ampersand n. We've taken this input now, so let's say for int I equal to 0, I less than n, I plus plus. So let's say in each, first they enter the name. Okay, so scanf %s comma. Now we need to store these employees, right? So let's define a structure for employees. Okay, we'll have struct. I'm gonna type def here itself. So type def struct employee. Oops, double p's. Employee, and then employee has a name, so char name, it's a 20 length. Then we have int id. Okay, and we have a date, okay, joining date. So let's call this as employee itself. Let's make a structure for date also. So we have, I'm defining it on top of this because I'm using it here. I don't want any errors regarding that. So we have type def struct date. Okay, and a date represents int date, let's call it int day, int month, and int year. Okay, let's call this date itself. All right, so date is there, employee is there, and now so scanning %s comma, let's make a new so let's make an array for employees, right? We need to save our employees somewhere. So employees, okay, of size n. Scanf %s employees of I dot name. Okay, scanf %d comma ampersand employees of I dot id. This I do not need to put ampersand here. I hope I'm not wrong because that's what I have learned. Let's see, we'll run it out. No expert will try it out, no problem. Then we have date, right? So for date we need to take 3 let's say we user provides us date in this given format. Okay, %d hyphen %d hyphen %d. Okay, and then we do ampersand employees of I dot date dot day. Let me just copy this and let's copy this, and yeah, so we'll have, let me just break this into another line also. It is not very, yeah, it was getting cut. So yeah, we'll have employees I dot date dot day, employees of I dot date dot month, and date dot year. All right, let's just quickly take a look and let's see if we can print it. So for int I equal to 0, I less than n, I plus plus, it's essential to make small increments in your code and check it out so that you don't make mistakes which are hard to catch later on. So let's printf %s \t %d /t %d hyphen %d hyphen %d. Okay, and this will be employees of I dot name comma employees of I dot id, oops, yeah, comma employees of I dot id name, and then employees of I dot day. Okay, and let me just break this into a new line here. We'll have employees of I dot date dot month, right? It's nested structure. So employees of I dot we'll have date dot year, right? Cool. So I'll move this back to here itself. So let's take it out. This code should work if we have done everything fine. So let's see. So not Python, it's C. Unique. Okay, let's give 3 employees. The first one's name is Shubham. Let's give the ID as 1. Joining date is 21st March 2020. Okay. Then let's give another, let's see, give the name as COVID. Let's say second, and let's see the 15th March. Okay, and let's the third username should be, let's say, Siddharth or something. Okay. Then let's give this ID as 3 and joining date as 16th March, 16/03/2020. Shubham 1 2020. Okay, COVID. We did not give space while printing, but yeah, I think date is, we are able to store the user's input correctly, right? And that's what matters, right? So let's continue. I'm going to comment this for now. But later, let me just remove clutter in my code. So now we have to do that thing we talked about in the algorithm. For int equal to 0, I less than n, I plus plus. Let's pick date. So for int j equal to 0, j less than n, j plus plus. Okay, if j not equal to I, that's the condition we have to use, right? Because obviously then everyone will get messed up, it'll get messed up, right? We don't have to do that. So if j not equal to I, let's make a variable as count also, right? So int count equal to 0. If j not equal to I and error of, so let's say employees of I dot joining, let's say, so check. So let's make a function to check if employees of, see, we cannot directly compare two date objects, right? Because we don't know, I mean, the C compiler will not know on what basis do you compare dates, right? So let's make a function to compute date. So we'll have something like, let's say, int compare dates, or let's say equal dates, int equal dates, right? So we'll have date d1 and date, let's call it as date A, date B, for easier, equal date. So if return, let's call it bool, okay, and have included boolean, yeah, return a dot date dot, sorry, a dot day equals a dot, sorry, b dot day, right? And this whole should be and with a dot month should also be equal to b dot month, and this whole should be and with a dot year should be equal to b dot year, right? So if these dates are equal, everything that they contain should also be equal. So day, month, and year should be equal. So if j not equal to I and equal dates, right? Employees of I dot date. What is the variable? We have date only, right? Equal dates employees of I and employees of j. Employees of j dot date, right? If these two are equal and j and I are not equal, then we, let's say we, so bool unique equals true, right? So this becomes false now. So unique becomes false because two different indices have same joining dates. We need, so if at the end of this loop we need reach somewhere where this unique is still true, let's increment our count and do count plus plus. Okay, and in the end let's just print this count. So printf %d count. Okay, looks good. Let's understand this once more. So we have a structure for date, day, month, and year. It contains day, month, and year. All three are integers. We have a structure for employees. One employee has its name, has its ID, and then has a date, a structure in itself. And we call this structure employee. Then we have a method to compare two dates. Two dates are same if the day, month, and year are same. So that's what we have done here. Return a dot day equals b dot day, and a dot month equals b dot month, and a dot year equals b dot year. Then we are taking input for n employees, storing them in an array, taking the name, taking the ID, taking the date of joining, storing them. Then we already have where we have a count equal to 0 to find out the number of unique joining dates. Then we initialize a unique as true. So we are assuming that the given date is unique. And while checking, if we find an index which is not equal to the current index and the date is same, then it's not unique. So we set unique equal to false, and then we do unique if we are able to find if there is no index which has the same date, then we set the count, increment the count, and then we print the count. So let's just run this code once. So let's give 3. Let's say Shubham, employee 1, joined on 20th March 2020. Let's say COVID, who joined us on 20th March 2020. And let's give Raj ID 3. He joined us on 21st March 2020. And we get 3, which is 3 unique. He says there are 3 unique dates. Okay, which is wrong. Let's see why. Okay, so we have a date comparison, something going wrong in that. So we get 3. So count plus plus is happening every time. If j not equal to n, equal dates employs I of date and employs j of date. And equal returns if 2 days are similar. So unique will be 1. Unique should be okay. So for 20th, it'll check. Oops, I gave 202 here. Okay, yeah. So it's my mistake. If you check these 3 test cases, they are different. So the year in this case is 202. This case 2020. So let's just quickly correct this and let's try it out. So Shubham 1 2003 2020, COVID 2 2003 2020, Raj 3 2103 2020, and we get one date which is unique, which is this one, right? All right, so that was the end of the second question, and now let's take a look at the third question. So the third question that we have is, let's just quickly take it. Oops, this doesn't look good here, right? So I'll just, yeah. So the question that we have is, given center and radius of n circles, identify the circles which can be concentric with circle 1 and lies within it. All right, so let's take a look at this problem now. All right, so this problem can be solved quite simply, again using structure to represent a circle. So a circle has a radius and a center, right? So we can represent a circle as it has, let's say, center which is x comma y, int x int y, and then we have a radius, so int radius. So 3 things a circle has. Now to check if if given a circle, if there are how many concentric circles and they lie within it, we have to check for the condition like how many circles have the same center as given by the circle which is given to us, and their radius is smaller than the given circle, right? And that's how we check for concentric circles which lie within the given circle. So let's just code this problem out, a very simple problem. So let's continue. I'll make consent. Oops, I should share my concentric underscore circles.c hash include stdio.h int main return 0. And what we're going to do is we're going to make a struct circle. So I'm going to do type def here itself, type def struct circle. It has a center. I'm not going to use a nested structure for circle, it's okay. So this is a small problem. Int y, then we have int radius. All right, let's say we're given n circles, so int n for int I equal to 0, 0 I less than n. Plus we need to store these circles somewhere, right? So we'll do an array of circles. So circles of size n, scanf, scanf. Let's say we are given percentage d, percentage d, percentage d, x coordinate, y coordinate, and the radius, and we do ampersand circles of I dot x, right? X, y, and this will be radius. This will be y. All right. So scanf is done. Circles are taken now. So we just have to find out all the circles. So let's say, so for int I equal to 0. So let's take the given input circle as well, right? So scanf percentage d, percentage d. So circle to find. Let's name this to find. So yeah, or let's name it as given underscore circle. Okay. Say ampersand. We'll just make given underscore. Oops. Given underscore circle. Given underscore circle. Given underscore circle. Okay. For int I equal to 0, I less than n, I plus plus. If the current circle, which is circles of I dot x, equals circles of given circle dot x. Let's make a function rather not complicate our main method. So let's make a function which returns a bool. So bool concentric. Okay, concentric. Let's include std bool dot h as well. Std bool dot h. Yeah, takes two circles. Okay, so circles c1, circle c2. Okay, so let's say if return c1 dot x equal to c2 dot x, I mean the center x coordinate is same, and so let's just wrap this in brackets so that it looks better. c1 dot y, oops, one second, c1 dot y equals c2 dot y, and c1 dot radius is less than c2 dot radius. Okay, so here we should write if concentric c1 dot radius should be less, right? So it should be like circles of I comma given circle, right? If they are concentric, then let's make a variable called count. So int count equal to 0. Oops, equal to 0, count plus plus, print f percentage d count. So let's compile this code. gcc hyphen 10 concentric circles. Ooh, we get so many errors because I did not define circle here. Circle, okay, that's the error. I undeclared ampersand given circle ampersand. Oops, sorry. So this will be ampersand given circle dot y. Okay, cool. So let's make an input file. So let's say we have 3 circles. So the coordinates are the center is 1, 2, radius is, let's say 10, and then center is 1, 2, radius is 1 2 5, 1 2 7. Let's make it 1 3 7. And let's give our given circle as 1 2 15. The answer should be 2, right? Let's try it out. It gives 0. Very good. So is this comparison we are checking if circles of i's radius is less than the given circle's radius. So yep, this is c1 dot x should be equal to c2. So 1 dot this is correct for int equal to 0 less than n. I'm not taking n only as input, right? So I should do that. Scanf percentage d ampersand n. Okay. Now let's recompile our code and let's run it. We get 2, which is correct. And now let's take a look at the third problem. All right, so the third one was a very easy problem, nothing difficult about it. Now let's take a look at the fourth problem. So the fourth problem that we have is given details of books, access number, title, author, number of pages, and is available, 0 not available, 1 available in a library, and title of a book that has to be searched. Write a C program to print the access number of the first book that matches the title. Matches the title. This means there's some kind of pattern matching and is available in the library. All right, looks like a nice problem. Let's tackle this. Let's try to solve this. So the data that is given to us is that it has, so the book has, let me bring myself closer to the mic. Okay, so the book has an access number, let's say call it as int access number. And then we have title, right? So let's say char title of length 50 maximum. Then we have author, right? So char author, okay. And the number of pages, so we have int pages, okay. And then we have is available, which will also be int is available. All right, so if I hide these problems now, you'll see what we have. So we have this structure for books, okay. So access number, title, we have author, we have pages, and then we have is available, okay. So we'll be given a string, which will be like given string find which book has this given string in title, has this given string in its title, and is available, is underscore available is equal to true. Right, it's a fairly easy problem, nothing difficult. Only thing we need to take care about is the pattern matching part. I think that C also has a method called str, so we'll look at that as well. So let's dive into the code and solve this problem, as it is a very straightforward problem, okay. All right, so let's implement this problem. So let's call it library.c hash include stdio.h. Let's say hash include string.h, yeah, int main, return 0. Let's make a structure for books as planned. So we'll have a type def struct book, we'll call it as book. Let's close this. We'll have int access number, we have char author, let's call this is size 50, char title size 50. We'll have int is available, and we have int char int. And then the last thing that we had is we had title number of pages, okay. So int pages. All right, now let's take the input. So let's say we are given n, not seen, scanf percentage d ampersand n for int I equal to 0, I less than n, I plus plus, scanf percentage s comma, let's make an array to store the book. So books of size n, okay. And let's see, first the user gives us the title of the book, so percentage s books of I dot title, right. And then we have scanf percentage s the author, so books of I dot author. Then we have scanf percentage s books of I dot access number. Let's say we'll have to put ampersand here. I'll just copy this so that we have access number, pages, and lastly is available. Okay, so after taking this input successfully into the books array, we'll also take a given. So char, let's say 50 title. Okay, scanf percentage s comma title. Okay, once this is done, oops, this is not all percentage. This should be percentage d, percentage d, percentage d. Yeah. Then we have char 50 title, so title is all, and then let's see. So we'll have to do matching as well, right? So str in C. Just quickly take a look at that. So yep. Okay, so substring is s2, and okay, so let's see. So let's say for int I equal to 0. So what we're gonna do is we're gonna loop over all the books and the given title. We'll just have to do str over it, and let's say a variable which is count, int count equals 0. We'll count. So let's say, so we loop over all the books and we'll check if the title contains the given string as a substring, and then we'll also check if it's available or not, right? So for int I equal to 0, I less than n, I plus plus, we do scanf percent. No, we do not do scanf, we just do count equal to 0. So if str of title, or rather we should do books of I dot title comma title, if these two strings, like if title is a substring of books of I dot title and books of books of I dot is available equals 1, then we do count plus plus. Okay, and then we simply do a printf in the end. So printf percentage d comma count. All right, so let's make an input file for this as well. So we'll have, let's 3 books. Okay, the first line is title, author, access number. So title, let's say Thomas calculus. I'm not giving space. You can do space separated input as well. For now I'm not doing that. Thomas calculus. The author is, let's say Thomas. Then we have access number, which is 1, pages, let's say 100,000, and is available is 1. Then we have, let's say Thomas rhymes. Thomas does rhymes, or let's call it rhymes by Thomas. Okay, then we have author as Thomas, then the access number is 2, let's say the pages is 500, and is available is, let's say 1. Okay, then we have another book, let's say Tom. So what did Thomas do? Okay, and the author is Thomas again. Let's make this author as Shubham this time, and then we have access number as 3, let's say number of pages 100, very slim book. Then we have the last thing, which is available. Let's make this 0. Okay, so this is not available, and then let's run our code. And the last thing we want to give is a title to search, right? Title to search. Title to search. Let's give Thomas. All right. We should get 2 as the output, right? So gcc-10. Let's say library.c. Yeah. Oh, again, I made the same mistake as Java. So this should be title of 50, right? Okay. Let's give input, so we get 2 as output. And if we make this also available, we should get 3 books, right? And if we make 2 of them unavailable, let's make this 0, let's make this also 0, we get 1 book available. And if we make that book also unavailable, we get 0 books. So this is the solution for the 4th problem, a very simple one, nothing complicated. You just have to organize things using structures properly, and I hope you are getting hang of structures now. All right, so let's see the fifth problem now. So let's quickly take a look at the fifth problem. So the fifth problem that we have is a virus signature is the fingerprint uh, of a virus. It is a set of unique data or bits of code that allow it to be identified. Antivirus software uses a virus signature to find a virus in a computer file system, allowing to detect, quarantine, and remove the virus. Given details of n viruses such as name of virus, signature, and size, write C program to print virus signature in descending order of size. Okay. Easy, right? So we just have to create a structure. Yeah, so we just have to create a structure and basically sort that array of structures on the basis of a parameter. So let's do it. We've already done it in a previous problem. So let's continue. So let's make this file as virus.c. I created a directory. Let's make file virus.c --include stdio.h, right? Int main return 0. Let's make a structure for virus. So type def struct, let's capital V virus. It'll have a int signature, right? Have int size. And what else do we have in a virus? We have name of the virus. Okay, we'll have char, let's say name size up to 50 characters. Okay. All right, so let's take an input from the user for int n. So scanf %d comma ampersand n. All right, this is done. Then we have so for take a loop, and let's take the input for int equal to 0, I less than n, I plus plus. We then take each and every, so we'll have a, let's say a array of viruses. So viruses of size n. So let's take an input. So take input. So scanf %d %s comma ampersand viruses of I dot signature ampersand viruses of I dot size and viruses of I dot name, right? So with these three taken, we just start to sort it. So let's say and we have to print what exactly we have to print virus signature in descending order, right? So let's sort viruses comma give the size. Let's for int I equal to 0, I less than, and we'll implement sort in a while. I plus plus print f %d comma viruses of I dot signature, right? Let's print it in new line, everything, maybe with a space, right? And then just do a new line in the end, right? Cool. So let's implement the sort function. So we'll have a void sort, right? And it'll take an array of viruses. So we'll have viruses, right? And then int n. Okay, then we'll just, let's do a quick bubble sort. So for int I equal to 0, I less than n, I plus plus. Oops, it should be I less than n minus 1. Then the inner loop goes from j equal to 0 to j less than n minus I minus 1. Then we have j plus plus. Now if compare, so if virus viruses of I dot signature is less than viruses of j dot signature, we should swap, right? So swap viruses of, oops, sorry, virus of j is less than virus of j plus 1 dot signature. Swap viruses of j dot signature and viruses of j plus 1 dot signature, right? So let's implement the swap method as well. So we'll have void swap. Let's pass these things by reference. We can change them easily. So we just get a pointer then, right? Signature is of type star, so we get a pointer of type star. Sorry, a pointer of type integer, and we get int star signature A and int star signature B, right? So I'm gonna do int temp equal to star SA, right? uh, Dereferencing it, then star SA becomes SB, and SB becomes temp, right? And then after this, I think sorting is also done. Yeah, let's just run this code. Okay, gcc-10 viruses virus.cpp. Why am I? Oh, I think again the same mistake which I did earlier. Virus, yeah. So we did not speak to temp. Okay, sorry, star is equal to temp. So let's make the input data for this. Let's say we have 3 viruses, one, and let's say the name is COVID. Let's make the size as 2, the size as name as COVID-19. Let's make the size as 3, and the name as COVID-20. And we should get the signature printed and sorted. Let's try it out. We get 3 to 1 printed, which is totally correct, right? We can also make changes to print the name as well. So let's print the name of the virus also, and just do this in a new line. Viruses of I dot name. This will look a little better, right? 3 is COVID. Oops. Okay. 3 is COVID. 1 is COVID-20. Okay. So how come the name is viruses of I dot name? Okay. We should just swap. Okay, swapping this is wrong. Okay. Let's swap. So we get a virus type here. We get a virus type here. Right, we can make a virus type here. That's all should work. Viruses of J plus 1 ampersand. Let's compile now. Okay, let me pass the input. Yeah, so we get 3 COVID-20, 2 COVID-19, and 1 COVID. So the problem was that when we were swapping this earlier by just the signatures, what happens is these signatures get changed, and so does so the value of signature gets assigned to some other value, right? So that's like we change the reference. So we may need to take a look at it anywhere, wherever we are doing that, wherever we have a swap method. So I think we have we did not use sorting anywhere, right? So it's fine. Cool. Yeah, so that's it for the 5th problem. I hope it was an easy problem and nothing difficult. It's just that you should know a sorting algorithm properly, and yeah, that's all. If you guys have any doubts, make sure to put them in the comment section. If you guys enjoyed watching this video, make sure to give this video a thumbs up and subscribe to the channel if you haven't already. And below you can see all my socials, so you can connect with me on Instagram, where you can ask me directly via DMs and I'll be happy to answer them. You can also follow me on Twitter, and you can also connect with me on LinkedIn. So I hope with this you get enough confidence with structures, and if you have any doubts, again, put them in the comments, and I'll see you guys later. Until then, take care. Bye bye.